Welcome to Diary of a Dreamer, where resilience unlocks your potential. I'm Tasha Eisinger, and each week I'll bring you powerful stories and practical insights from my own experiences and inspiring guests. Whether you're facing challenges or chasing dreams, this podcast is your go-to for motivation, building confidence, and practical tips for transforming obstacles into opportunities. Be sure to check out my website, tashaeisinger.com. Let's dive into today's episode and start turning your dreams into reality. I'm going to have to look at my notes to introduce you because you have quite the intro here, Marsha. And just a side note before we get started, I am not a homeschooling person either.
Okay.
And so have you been to the Midwest Expo?
No, Jean reached out. She ran across my books
Okay.
And invited me to be a speaker. And I thought, wow, what a perfect opportunity to engage with really a core part of the audience I'm really trying to reach through my middle grade STEM adventure books and my experiments. So I figured that's really the perfect balance for parents and teachers, grandparents who are looking to get their kids engaged in STEM.
Yeah.
Story changes attitudes, and the experiments are learning by doing. But the other piece from my personal experience is just the power of choice and hobbies. And so some of my background, I'm an engineer with bachelor's in mechanical engineering from Purdue. Then I joined GE Aviation in 1981, did a master's of science in aerospace engineering through their advanced course in engineering, did that in 84. And then I had a 3-year assignment as manager of technical education programs from 1990 to 1993, managing GE's advanced courses in engineering. And I worked with Mark Willem Fowler from UC's Teachers College, learned what I wish I had known when I was going to school about effective teaching methods, rediscovered the joy of learning, went back to mainstream engineering and did a PhD in materials engineering while working full-time at GE. So I have all this different experience, but the one point I want to share is sophomore year at Purdue, physics courses are generally flunk out courses. I got my first D ever.
Oh, how did you handle that?
It's like I went home at Christmas break. It's like, shit, can I do engineering? Am I cut out for this? And my parents were not happy. They weren't going to send me back to Purdue unless I got things turned around. And the thing that I reached back, that was my rock, was all the creative stuff I'd done as a kid in grade school, middle grade, all my hobbies, sewing, designing furniture with my dad, painting, all those things. I was used to dreaming up projects, figuring out how to execute them on my own. I didn't have a teacher telling me, here, we have an hour to complete this project. Turn it in. It was all those hobbies where I learned project management, industrial engineering for workspace setup. Where do I put my sewing machine? I use the ripper and the scissors often, the screwdriver to change needles. What's effective workstation layout? You get used to also your pattern layout, how to start from start to finish, and you fail. You don't learn to sew without ripping. And you come up with less than perfect creations, and you learn to accept them and love them and do better the next time. So through all of those hobbies, at the time I was thinking, okay, I'm a creative person. And engineering is just another medium. With what I know now, I would say I learned problem-solving skills through my hobbies. And I learned to succeed and fail because the motivation was built in. I didn't quit. It was fun, so I kept going. I just figured out a better way. And some of the engineers and I at GE, we kind of laugh because GE had this habit of coming up with another quality initiative, bring quality to life, continuous improvement. Like they were going to teach us engineers how to continuously improve processes. Like,
Wired in
we
you.
learned that through our hobbies. And so, yeah, they bring, Six Sigma brought a lot of statistical tools that we didn't have. But what I learned was, man, that creative stuff that I did as a kid in middle grade, before I got heavily scheduled and had all these extracurricular activities, I had, my mom was a stay-at-home mom. I grew up in the 60s. You know, I had the luxury of, she led the Girl Scout troop, so she planned activities for Girl Scouts. So we had a lot of creative activities there. We did things as a family. We collected butterflies. Dad was a very creative. He was a non-degreed industrial engineer. He was a veteran of World War II. He could have gone to college on the GI Bill, but he lacked confidence in his math skills. And so my mom saw this as, man, my husband could be earning a lot more money than he is now. He could be advancing further in his career. He doesn't have a college degree. He didn't have confidence because his high school dropped him from math courses, and he got extra English courses, which served him well, but he lacked that confidence in math. And what I've learned through my volunteer activities with the Greater Cincinnati STEM Collaborative is that's common today.
It
Lack
is.
of confidence in math skills is the number one barrier to success in STEM. And my mom looked at my dad and said, my daughters are, they're going to take math seriously. It's important. At one
You
point,
use it every day. Whether you like it or not, you use it every day. Even if you have a calculator, I used to teach my students that even when you use a calculator, you have to know if the calculator's right or wrong, and you have to know
yes.
which numbers to input and how to input them.
And you need to not be afraid of math. I mean, the attitude is so important. It's like, and the thing that I've found is like, teachers don't really understand what engineers do.
Okay,
They,
let's backtrack. Can you
okay,
explain? Because there might be listeners. So I
okay.
grew up with an older brother who um he was always taking things apart to see
Mhm.
how they worked. He's a mechanical engineer. He's brilliant at what he does. So I've seen it from the inside growing up with that, and how he can figure out pretty much anything. I mean, he really can. It's just how his brain works. He sees, like a structure. He's like, well, this is how I would do it. And I'm like, how do you know? And it's just amazing. So can you explain to everybody who hasn't had that sneak peek of an engineer's mind, what do engineers do?
In the very basic of terms, engineers solve problems.
Mm-hmm.
And they go to school to learn the physics and the science behind the type of problems that they are going to solve. For example, a chemical engineer has to understand what chemicals they put together and what products are going to come out and how to safely combine that to make something new. A mechanical engineering so broad.
Mm-hmm.
Um, I ended up um, focusing more on structural engineering. So, like in the structures, you might need to know, okay, how much stress can this engine component withstand before breaking? What are its failure modes? When is it going to fail? What are the consequences of failure? And from an aircraft engine perspective, we're really interested in this because a critical rotating part, if it fails, could exit the engine, be an uncontained failure, could enter the fuselage of the aircraft. It could cause loss of aircraft, loss of life.
Right.
So there are methods for designing that use, well, you can use the old-fashioned method, which was you just test. The old-fashioned, before we had computers,
That sounds
you
like
would
it take
test something
forever.
you would test something and you try to figure out what works and why. And then
Yeah.
you have people like Newton who figured out gravity and figured out the formula for that. It's like, okay, now I have a formula. I can predict it using math. So in many engineers, not all, will use computer models or math models to predict how something's going to work.
Is it kind of like running simulations then?
It can be, but I
Okay.
think of a simulation as being one specific condition.
Okay.
And like for engine components, we would build finite element models of all the engine structures and the blades. And the people who did the detailed analysis, they'd figure out how to put the loads on it, how to spin it up. We'd have mission analysis engineers who would figure out what's the plane going to do? It's going to take off. How long is it going to take to take off? How long is it going to take to climb? How long is it going to be at cruise? And it would have to figure in the temperature, ambient temperature mixes of all the airports around the world, the pressures and temperatures, all the things in the engine cycle that affect the pressure and temperature speeds of the engine, what it's encompassing. And then the finite element people map all that onto the finite element models. And then the life engineers, we marry that with the materials engineering data. So we get a stress and temperature history for critical locations. And we put that into a life curve and figure out, how much life is being consumed.
Okay,
So
so I have to backtrack here for a second.
okay,
You are doing a great job explaining very complicated things in a
okay,
way that I
but
can
it's over the board.
understand.
Okay.
Because so I also have a Purdue education in elementary education, not in anything engineering. So the fact that you can explain it, this tells me a lot about you as a writer and probably why you're an award-winning author and why you have these programs for kids.
Yeah.
Because you can take these very complex things and simplify it so anybody can understand, right?
So a
That's
simple
smart.
explanation I can show you. Okay, here's a ruler.
Yeah.
Okay, engineers, we can develop formulas for all kinds of things. How much this ruler is going to deflect based on the dimensions and the cross section of this ruler.
Okay.
Okay, but if I stand it on flat like a diving board, there's a lot of deflection here. If I put it on its side like an I-beam, it's very stiff.
Huh, yeah.
So that's something you can do at home with a plastic ruler, a plastic knife to understand, here's the power of math and algebra that can predict based on the geometry of any object and material properties. And you don't even have to know the material properties to know I turn it on the side, it's going to deflect more. I turn it on its end, it's going to deflect less. You can see that from a formula, and that one is in book 2.
I love that because when I was at Purdue and, Purdue's very science heavy, even in elementary education, there were so many cool experiments and things that you can do to make it these formulas and things that seem out there and hard to understand, very understandable because it's tactile. It's something that you can play with and learn by doing instead of just reading it. So you've incorporated books, which I'm excited to hear about your books too. I'm also an author of children's picture books.
Oh, I love
And
that.
yeah, I can't wait to meet you at the
At
Midwest
the
Homeschool
West
Expo.
Homeschool Expo in Indianapolis on June 28th.
Yes.
Meet me and Tasha there. We'll see you
Yes. Yes, we would love to meet you. And I can't wait to meet you, Marsha, because I think a lot of what we're doing really goes together well. And it's all about building the foundation in kids. You build a
Yes.
strong foundation, you have a stronger future. And that's what I'm hearing you do.
And the other piece that I've learned, so I've done a lot of reading in a variety of fields, but one of the books I've read is the 10,000 hour rule, where talent is overrated by Jeff Colvin. And he talks about the 10,000 hour rule. Like Mozart and Tiger Woods, many consider them geniuses, but were they really, or did they just start at a younger age and they had expert tutoring in a very specific discipline by their father, so that by the time, their peers were starting in music or golf, they had years of deliberate practice on them. So they were just that far up on the learning curve. And what I've concluded from my own life experience is all that stuff I did as a kid, my creative hobbies, I was learning creative problem solving skills.
Yeah.
And that is the most transferable of all content taught in school. The other main things are facts, concepts, and generalizations, which are very specific to a particular discipline. So the facts for vertebrates versus invertebrates, that's going to look a lot different than the facts for buoyancy or, density of water. So I feel like I had a lot of time doing creative problem solving. And it didn't have to be in mechanical engineering. It could be in sewing. It could be in painting. When you're doing arts, you're also releasing this creative side of your brain, and you're not afraid of failing, which is another key thing that doing this through play and hobbies empowers kids, because they don't have a parent judging their art homework. Almost everybody's going to say, yeah, that's good. And as a budding artist, I'm thinking like, okay, I'm trying to communicate something and I have to figure out how to mix my watercolors and I have to figure out when to stop. So or if I'm doing clay, it's like, how do I get the texture I want? Or how do I check different glazes? Okay, budding engineer, I actually did a high school, I took art in high school because I was between art and engineering. Those were my career choices, and
So you're a
engineering one.
creative and a scientist, which also goes hand in hand.
It does. And I
They
think
both help each
women
other.
are more likely to really embrace both sides. I think my experience is guys tend to get really tunnel focused and deep, and anyhow, but that's my opinion. I have no data to back it up.
You're
But
allowed to have opinions here. It's fine.
I found there was one time I was trying to figure out, okay, so I have this, I still have it in the basement. I have a planter, a red clay planter I designed. I did the base, so I did two pieces. I had a little watering hole on the side, and I wanted it to look like a log. So I figured out how to take the bark from a tree and roll it in the clay on the outer side that I attached to the inner structure to give that texture of bark. But red clay, you can't tell what the glazes are going to look like very well because you're putting it over a very different substrate color. So I actually did a blank grid. I drew, lines. I scored lines across it. I tried different glazes across one side and base glazes in the other to figure out what glaze was going to give me my favorite bark color. So that was Marsha pre-engineering days, trying to do a design experiment to pick a glaze color for my clay project.
I love that. That was you laying the foundation for your engineering days for sure. So what I'm hearing from you is hobbies are important.
Yes.
Kids being allowed to make mistakes and learn from them is very important. So what do you think parents can do to help their children be better problem solvers? Because we need that. Our world needs people who aren't
Yeah.
just whining and complaining, but are solution oriented in solving problems.
Okay, so I'm going to go in a little bit of a tangent here. I'm going to bring in my dog training experience because good dog trainers teach their dogs to be problem solvers. And actually, I think Dr. Daniel Amen said this in one of his books. It comes down to notice what you like more than what you don't. So be positive and reinforcing, but don't step in to criticize, correct, or complain. So you've got to step back and allow your kid to make mistakes, which can be really hard if you want them to be perfect. I mean, my parents, I have to admit, they were helping me with my school projects in third grade. I built a big ocean liner like Titanic out of cardboard, and my dad was down there in the basement helping me. And another kid carved a boat out of ivory soap that floated. And I thought, that kid probably did that project entirely himself, and what a creative solution. So I think the hardest thing is trying to encourage your kids to strive and be excellent. Provide motivation, help them set goals, but you need to step back and allow them to choose. And there are times that you just have to say, hey, wrong is wonderful when you're learning. I'm not perfect. They're not going to be perfect. But really, and there's another rule of thumb that it takes like 5 or maybe more positive interactions to overcome every negative interaction. And I've seen people, with their kids, it's like, don't do that. You know better than that. It's like they're nagging at their kid continuously, or their grandkid.
Yeah, and that becomes their self-talk, right? As an adult,
Yeah.
that's the voice that they hear, is the things that they're doing wrong and all of that. And I also want to point out the fact that you mentioned your parents weren't perfect, right? Your dad helped you, maybe a little more than he should have. So parents, take the stress off. You don't have to be perfect, right? But you're right. They've got to fail. They got to make mistakes and learn from it. There's actually a book called Mindset by Dr. Carol Dweck. Have you heard of that one?
I gotta look that one up.
Yeah, you'll get the concept within the first short little bit. And it drastically changed how I use positive reinforcement in my home.
Hmm.
Because you're right. If you focus on the negatives, you're going to get more negatives. If you focus on the positives, that's going to encourage and build up your kids, right? And so encouraging the process of, I love seeing how you overcame that challenge, or I see how determined you are versus the finished product of like, wow, that looks amazing. It's perfect,
Yeah.
right?
And I think that's the other thing, like with dog training, Mooney, okay, I've been learning to train dogs since like 1987, so like over 35 years now. But it wasn't until I had a seminar with Susan Garrett that it really, the clicker training, I really got it, because her mantra was value, choice, balance. So for the dog, okay, the value piece is, what are they going to earn as a reward if they get it right? So why should they bother to solve my problem instead of their problem? The choice piece is, I've got to allow him to make a mistake. So there's and another side piece is, you got to believe it's possible too. And then the balance is, hey, problem solving is hard work. So you don't want to sit and do it for 8 hours at a time. You need to get up and move and take breaks, you know, change it up, shift gears. If you're in the zone, that's another thing. But like especially for dogs where there's no verbal communication, I can't tell him what's right. He's trying to figure this all out, just like the game hot or cold. If you're getting closer, you get feedback that you're getting warmer. And if you're not, you get the feedback that it's cold, and you can take a different approach. So that's kind of, with dog training, the whole philosophy is, okay, my goal might be the box trick where I need Mooney to put all 4 feet in one box. Okay, I can't tell him what the goal is. I can lure him in a box, but it's like getting to a destination using GPS. I don't learn the route. I'm just having GPS lure me to the destination. And that's what luring is for dogs. Whereas if you set it up as a problem and there's a goal, okay, his goal is to earn the treat. Okay, so my first reward might be, he looked at the box, and I've got a big box to start with that's big enough for him to stand in comfortably. My goal is to get to a really tiny box where he can only get his 4 feet in. For
Okay.
years, I couldn't get there because I couldn't imagine how a big golden retriever could get his feet in a tiny box like that, until Susan Garrett said, think about their position when they poo. Ah, got it. Okay, so now Marsha believes it's possible. Now Marsha was able to teach her dogs the box trick.
I love that. Well, and relating it back to kids
Hmm.
as well, the parents have to believe their kids can learn through their mistakes,
Yes.
and it's actually making them stronger and more capable. And I know it's hard. It's hard to watch anybody, whether it's a friend or family
Hmm.
member, your child, whoever it is, make mistakes and be frustrated.
Hmm.
But thinking back to your D in
Hmm.
college, that was a defining moment in your life.
It was,
It changed the course of your future, don't you think?
definitely. It would have gone very differently. I couldn't even imagine what career I would have chosen as an alternate to engineering, but I'm so grateful that I chose engineering. The other thing that I had to change to make that transformation possible is, I had to take responsibility for my own learning. So I
I
had
want
to,
to clap right now hearing you say that. When I was teaching, I was the same teacher to all my students. It was the kids who took responsibility, the parents who had their kids take responsibility for their learning,
mhm,
as well as, the parents who were teaching them things at home, nothing fancy, but just interacting and educating at home. That makes all the difference in the world. So I hope
mhm.
everybody heard you say taking responsibility for your own learning. So your parents didn't come in and go to Purdue and say, take away her D, or right?
No, 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 no.
You had to take responsibility.
And so I had to think back, okay, I'm smart. High school, I was basically an A student. Purdue, I was kind of like, okay, I was number 5 in a class of like 844. And I had um, two art classes that were level 3, as opposed to the accelerated classes, which were, so an A for art counted the same as a C in calculus. So,
Okay.
and I still ended up 5th out of 844. But when I thought back to okay, I kind of let my grades slide a little bit. It's like, okay, so the B's, there were some A's and B's and the occasional C, but that D was a wake-up call. It's like, okay, I can't slough this off. I have to step up and figure out what I'm going to do to change. So I thought back to, of all things, biology in ninth grade, maybe, because I just aced every test. But what I realized is I wasn't studying to pass a test. I was studying to learn the material, and I understood whether I knew the material or not. So
That's a
just,
huge difference right there.
mhm,
Most people can study for a test,
mhm,
but they don't retain it.
yes,
Learning the material locks it in for life, right?
yeah. And when I realized that, then I realized, okay, I can't, it's not okay to say, okay, the professor didn't want to teach or the TA didn't speak English. It's like he had me thinking, current got invented at nodes the way he graded one of my homework papers. It's like, okay, but it's on me because I knew I didn't know that. So a significant thing that happened the next term, okay, EE 201, linear circuit analysis. And I have a 7:30 lecture in a big
Oh,
auditorium with like 300 people and multiple guest tests. And it's like, oh no, this is a recipe for disaster.
it sure
But
is, especially at that age.
mhm, but Purdue offered an independent study section, and I transferred into that. So, and okay, so this would have been, oh,
How did
actually,
you
this,
learn about that, by the way? Sorry to interrupt, but how did you learn about the independent
I think the
study?
professor mentioned it. He
Okay,
said if you didn't want to be in this, he mentioned what the other options were. So I,
okay.
I started at Purdue in 1977. So this would have been 70, probably spring of 79. So my point is we didn't have videos. We had tape recorders. So they had lectures on tape recorders. You could go into this study lab and you could listen to the lectures on the tape recorder. You could read the book, and there was homework, and there were teaching assistants that would help check your homework. And when you were ready, you would go up and say, I'm ready to take the test. So you didn't take the test until you were ready. Now, the problem with this is that probably 75% of the students who switched into independent study didn't finish the course. Okay, and I probably finished the last half of the course in the last quarter of the semester. So
Of
I
course
was,
you did. You're a college kid. That's what college kids do.
yeah, but the problem is I passed with an A and I knew the material. And that material, okay, the cool thing about engineering and math is like differential equations. All you have to do is change the name of the variables, and you can solve the differential equations for electricity or mechanical engineering or fluid dynamics with the same set of math. In fact, before there were digital computers, there were analog computers because a capacitor in an electrical system is the same as a mass in a mass spring damper system. And a resistor is the same as a damper. And let's see, that would lead the inductor is the same as the spring. So basically, you learn how to solve one set of differential equations. You can solve it in any discipline you want.
I
And
love that. It's learning the rules. What are the
yeah,
rules? What are the formulas? How do
mhm,
they connect? It's kind of like life too.
yeah.
Once you learn the rules of life, you can play the game of life better, right?
And that's the whole problem solving thing. Purdue, I mean, and I'm sure it's not just Purdue, we had a very rigid, here's your homework problem, assumptions, you know, or given. So you do your problem statement, what the given information is, what your assumptions are, and then you'd start on your solution, and then you're supposed to summarize the results and discuss them at the end. But it's like, so you break it down. Clearly, what is the goal? What information do you have about the problem? What do you have to assume or guess to make it work or to figure out a solution? And then does your solution make sense? Did it actually solve the problem, or did you go off the site? So, and in life, you can use that basic approach for almost any problem. You may not have the right information. You may not have the right education to solve that problem, but you can probably figure out, I got a leak in a pipe. Maybe I need to get a plumber to take a look at it.
We have so
So
many resources at our
we do.
disposal nowadays too.
And
So
Google.
yeah,
So many things that you can look up. So it's not about knowing everything, but if you know how to tackle a problem, you know what, if you can define what the problem is and what the problem isn't, it's like a little bit like playing Nancy Drew or MacGyver. It's kind of like, okay, what don't I know here? What do I need to figure out? And then who can help me figure that out?
absolutely. So do you do that type of problem solving within your books? Can you
Yeah.
talk a little bit about your books?
First started writing, I was just writing, and it's like I had an idea in mind, but I had to clarify my message, and I realized, okay, Putney and the Magic iPad didn't talk about anything that the books were about. And when I got through 3 books, I realized I'm inventing stuff in every book. I'm solving problems. In book 1, I introduced rapid prototyping. So book 1 started out with a combined science fair art project that was going to be the big drama through the book. And Putney was wanting to enter both, and the mean counselor said, no, you got to pick one. And she figured out how to do both with one volcano experiment. But I needed more conflict between her and the other, her nemesis. Putney has moved from Kodiak, Alaska. Her dad's in the Coast Guard, to they're in the Savannah Air Station, but they're staying with their great great aunt Gertrude on Hilton Head Island. So she's thrust in a terribly different environment. And so they're close to the beach. And in art class, they're within 5-minute walk of the beach in their school where they're located, which was a place that was vacated after Hurricane Matthew and was vacant for years. So I made that my fictional school. But I thought, okay, in Girl Scouts, we had sit-upons. So what better project to throw at the kids than to design their own sit-upons using things that they have on hand at home, so they can go sketching at the beach or at the neighborhood lagoon. So it's actually an art class that she gives her first design project. And Mr. Shelley, who's named after one of my favorite art teachers, tells them about rapid prototyping. It's like, hey, just if you got newspaper in a garbage bag, you can make something. Figure out what you want, then tweak it. So Putney and Sue get into this design challenge, and Putney also has this cool Magic iPad with an amazing AI interface, holographic interface, who kind of coaches her. Okay, what do you want? And they use this rapid prototyping process with some big IKEA bags to quickly figure out what size it needs to be. So just by folding it down, okay, and a very simple math model, a ruler, okay, how wide, how long, how much do you need to cover your derriere? And do you want it to carry anything else? So your sketch pad, some pencils, it could double as a carrying tote while you're at it. And how much cushion do you need? So back in the days in the 60s, we folded newspaper, and we actually wove newspaper together for the padding of our sit-upons. And we had a heavy oilskin cloth on both sides. The perimeter was punched with holes, and there was a heavy cord that we looped through it. So these were somewhat heavy, but you could tie it around your waist. And I thought, okay, let's design a sit-upon for this century. And so I used bubble wrap, and I thought, well, will it pop? So I plopped down on bubble wrap on the patio, and it didn't pop. So it's like, okay, I have lightweight waterproof padding. I took smaller grocery recyclable bags, the kind of Tyvek bag, and found one with really cool surfboard and old 60s station wagon design on it. It's like, okay, and then folded it down, figured out how big it needed to be. So Putney and Sue end up in this competition where each day they're tweaking their design. And Sue's attitude is, okay, she's a rich girl. Anything you can do, I can buy better. So she brings in a Smith and Hawken garden kneeling pad the first day. And Putney's here with, she did a little sewing. She stitched 2 seams to cut the bag down to the right side, didn't change the handles. Day 2, Putney's figured out, well, I really want a tarp. And she did the tarp with the trash bag at first. But day 2, because she sews, she's got marine grade fabric, she makes this folding sit-upon because she likes Sue's design. It was bigger. So she does it. She, takes it out and So she does the folding sit-upon option. Sue comes back with one of those backpack beach chairs. Okay, which is about 8 pounds. So it's a lot heavier. Putney stuff is like under a pound, but it's got pockets, it's got a cooler. So, they're taking two very different approaches to the same problem, and they're all portable. Day three, Putney's figuring out, well, even though I could expand the sit-upon in one go, I really want more of a tarp underneath me to lay out my stuff. So she adds a tarp to her folding sit-upon option. And Sue comes back with a tripod chair that's a little bit lighter, but it's still a chair. And then day four, Putney comes back with, she goes back to her original concept because she liked the cool artwork. But she makes a custom handle, so she's got the nice crossbody strap on it. It's lighter weight. It's got a zipper opening. She can stick her sketch pad in there, and she can fold the tarp in there too. So she's got the tarp, and it's a little bit lighter weight than the folding solution. And Sue comes back with, I guess you'd call it a stadium chair, which is, it folds, but it lays on the ground. So, so Sue's going the expensive, I can throw money at this.
Which is not fair. I know life's not fair. And, but as a kid, if I was reading that, I'd be like rooting for the other kid, right?
But the thing is, it's like you can throw money at things and not come up with as good of a solution.
That's what I love that you're teaching, because kids are going to read it and be like, this isn't fair. But it's like, but that doesn't mean just because there's fancy stuff that it's going to work any better. So,
right. And the other thing is that, we didn't have a lot of money growing up. And what I've read since is like, hey, having less stuff makes you more creative because you got to get more inventive.
You're so much more resourceful when you have less materials and have to actually study those materials and determine how to make them work, right?
Yes. And so that's why, anyhow, so that's why I ended up writing these books, which my goal is to create a Nancy Drew meets MacGyver kind of feeling, so that you get the brave Nancy Drew, who's the champion for the weaker, very integrity, solving mysteries, but the mysteries are more science and invention related. So kind of a young MacGyver, and not heavy off the deep end in all the science and the math, but
you have me
creative
wanting
problem
to
solving.
read them. You really do. You have me wanting to read them because I'm already bought into the characters and who I want to win.
Yeah.
You've done a great job with character development.
And the other cool thing I'm working on this year, people have been asking me about this for a few years, but because of the homeschool conference, I wanted to try to think, what can I do to really help homeschoolers make these books even better for them? And a principal where I did a school visit with once said, if you had experiments to go with your books, now you'd really have something. In the back of my mind, I was thinking, I just spent 4 separate hours leading the buoyancy experiment for 4 different classes at this school. But one of my fiction coaches said, he's told me the same thing, as a parent, I would love to have 6 to 8 projects I could do with my kid based on your book. And when I was asking other homeschool author friends, they were saying novel study, and instead of individual experiments, do one resource with all of that. And so that's what I'm working on. I will have 7 experiments for this first book, Putney, The Secret of the Magic iPad. Plus I'll be doing novel study, and I'll have like a crossword puzzle and vocabulary, so that you'll get to dig deeper into the story. And so you can fulfill your English and science and math requirements with one of my books.
I love that. And, I'm not a homeschooling parent. I'm also, of course, attending the Midwest Homeschool Expo, June 28th in Indianapolis. Very excited about it.
Yes.
But even though I'm not a homeschooling parent, that is something that I would want in my home, right? Because we want kids exploring and learning and being curious and using their hands and getting away from devices.
Yes, and I think that is the thing. I mean, I've been volunteering with Girl Scouts of Western Ohio since 2015. I've been developing experiments for their Year of the Girl STEM summer camp when they added that in 2016. So I love working with kids. I really feel like middle school especially is a magic age because they know enough to grasp some of the harder concepts, and they're pre-algebra, and I can change their attitudes about math and show them the magic of math and why they want to bother to learn it. The hardest thing I ever did in 7th grade, I think it was maybe pre-algebra or algebra 1, but I got a C on a test.
Uh-oh.
I could not understand word problems. I was struggling with word problems. So I had to do a very hard thing. I had to go to the teacher and ask for help, and I stayed after school to get that help. And it took me a while to get the trick of word problems, but once I got it, I absolutely loved it. And that set me up for success. So the teachers out there, they just want you to succeed. So if you struggle with something, don't let an older relative who struggled with algebra change your attitude about it. My mother told me, "Oh, physics is hard. You don't want to, I didn't take physics until senior year, and I loved it." It's like, so don't listen to your parents if they weren't good at a subject.
Yeah, you are
I,
your own person,
you
right?
are your
Each
own person.
person is your
Believe
own
you can
person.
do it. In
Yeah.
3rd grade, I thought, good grief, I'm never going to be able to learn the
Oh,
multiplication tables. And
yeah.
I stressed out about that for like 10 minutes before I realized, well, my sister had to do it. I'm related to her. If she can do it, it's probably possible. I guess I can do it. So I stopped stressing about whether I could do it and just worked at it. So if you just say, hey, I can do it, don't even worry about whether you can. The other thing I struggled with, because probability and statistics was always taught the last week of the school year. So I never really got comfortable with it. So in my mind, I was always telling myself, I'm bad at probability and statistics. First of all, watch your mental language because words matter. Our brains are like computers. They believe the words we feed them.
Mhm.
So feed your brains positive messages. And when I was working on my PhD, I was doing some really cool experiments, and I needed to understand probability and statistics. And I was, so I took a couple probability and statistics course at UD. And because I had a purpose, I had a relevance. Okay, that's the other big secret, parents. Motivation leads to success. It has 2 dimensions. One is ex expectation for success and perceived relevance. So if you think it's useful, you're more likely to be motivated to learn it. And if you believe you can do it, you're more likely to do it. And you can set yourself up with smaller steps. So, back to the box trick for Mooney. I didn't ask him to put his feet into a tiny box. I asked him to notice the large box. I rewarded him for that. And when he put a foot in, he got another reward for that until he had all 4 feet in. Once he got the problem, I could make it harder by making the box smaller. So back to probability and statistics, they were my favorite classes at University of Dayton. I learned so much. I did this cool analysis, and it's like, so don't tell yourself because you struggled with something earlier that you can't do it now. Just monitor your motivation, make sure you are motivated to learn the subject. Ask your teacher or your parents for help if you can't see the point of learning this material. And then just figure out how to make yourself believe that you can do it.
I love that. Such great words to live by, Marsha. I cannot wait to meet you in
Yeah,
person.
same
It'll be
here.
so much fun. So we will definitely connect in June, on June 28th, of course,
Yes.
in Indianapolis, right? Probably want to get in touch with you. So how can they get connected to you? Of course, I'll include the link to your website. Do you have any freebies or promotions that you want to
Yes.
offer as well?
Yes. So I have a 3 volcano experiment bundle, which will be featured in the upcoming resource guide for the Secret of the Magic iPad. So that is hot off the presses. Still in the process of proofreading, getting feedback, seeing if I need to change some figures around. But we have the paper mache volcano featured in book 1. Okay, that's a paper mache structure. I actually made this with 2 of my great nephews in Virginia and painted it, and we did a dry ice volcano. So experiment number 2 is the dry ice volcano. I've also done that in a dog dish with the blocks of ice I get with Mooney's Ollie fresh pet food. So there's different ways to do the dry ice volcano. And then the third common volcano experiment is baking soda and vinegar. And I figured out a way to waterproof my paper mache volcano so that you can do vinegar and baking soda even with a paper mache structure.
My girl just did that the other day. I have an almost 10-year-old and an almost 4-year-old, and they were playing with baking soda and vinegar. It's such a fun experiment. So I cannot wait to see that.
It is. And what I discovered, every experiment I tackle, I kind of make it my own, because it's like, okay, I got to try one more thing. Would it work better with this? Do I need to mix this with water first? Do I need to, add the soap to trap the oxygen? And, and with the paper mache, it's like I was stressing out. It's like, there's got to be a way to waterproof this more easily than spraying with Krylon or something. So plastic tablecloth, that's my secret. And it's suspended the cup so it's super easy. And I've got the experiments include either step-by-step photos or in most cases videos as well. So you can see actually what I did. And, I went over the top with vinegar and baking soda because I ended up with I did a couple before I did it in the volcano, and then I did another 3 tests with the volcano to figure out what gave me the best reaction.
Oh, so fun. You live your books.
I do.
Which I love, in real time, and you're writing about it and creating experiments for all of us to benefit. So thank you so much, Marsha. I'll make sure that your website is in the captions or whatever it's called.
Yeah. So if you sign up to get my copy of the Volcano Bundle, you'll be added to my email list, and you can just reply to any of my emails and I will get your note. I read everything. So you can ask me any questions you want. And if you have any suggestions for future experiments or plots for future books, just reply and let me know.
All right. Thank you, Marsha. I appreciate your time today.
Thanks so much.
Thank you for tuning into this episode of Diary of a Dreamer. I hope you found the stories and tips shared today to be a source of motivation and strength. Remember, every challenge you face is a chance to grow and move closer to your dreams. Don't forget to subscribe, leave a review, and share this podcast with anyone who could use a boost of encouragement. Please check out my website, TashaEisinger.com.